Hello my dear friends, welcome to Live Prep. In the previous lecture, we studied about the cardiac cycle. Now in this lecture, we will study about the stroke volume and cardiac output, and after that we will go with the ECG. That's it. Only this much we are studying in this particular lecture. But before directly going into the stroke volume and cardiac output, once again, let me quickly revise that information regarding the cardiac cycle. In simple, so please try to understand this. So here we are starting with joint diastole first. We are starting with this so that it will be easy for us, and then we are talking about atrial systole, yes or no? And after this atrial diastole will occur, but this time is actually overlapping with ventricular systole, that means ventricles are undergoing systole, but at that time atria are undergoing diastole, relaxation. Next one, after this ventricular diastole will come. So in this way, now again initially here this is ventricles are in systole, here it is in diastole, but after again both of them are in the diastole. Now it is called a joint diastole. Once again it will be repeated. Yes or no? Now let us quickly go through this information. So first we are talking about the joint diastole. During the joint diastole, what happens? Now here this tricuspid valve and bicuspid valve, both of them are open, so that passively the blood from the atria are coming into right atrium. This is the left atrium, this is the right ventricle, this is the left ventricle. Yes or no? Deoxygenated blood from right atrium is coming into right ventricle, and oxygenated blood from left atrium is coming into left ventricle. Nice. And not only this, and this right atrium is getting blood from the body parts, deoxygenated blood, and left atrium is receiving oxygenated blood from the lungs. This is what happening in the joint diastole. In this way, ventricles are passively filled here. Yes or no? And in this way, 70% volume of the ventricles is filled by like this only during the joint diastole only. After this, what happens? Is from the SCA node, the wave of contraction, it is also called as the action potential that is passing through both the atria. And at the same time, it is also passing to AV node. Yes or no? And during this time, what happens? Atria are undergoing contraction, but ventricles are still in relaxation. This contraction of atria is called atrial systole. Yes or no? Atrial systole. Because of this, what happens? From the right atrium, deoxygenated blood will come into right ventricle. From the left atrium, oxygenated blood will come into left ventricle. This is what happening. So in this way, because of the contraction, forced filling is taking place for the ventricle, and this is contributing for approximately 30% of the volume. Clear? This is what they are saying here. With this, atrial systole is completed, and this is duration is 0.1 second. After this, for the remaining 0.7 seconds, it will be under the diastole, so that it is keep on collecting the blood from the corresponding or the respective organs. Clear? Now we are going with ventricular systole. Now ventricles, since they are filled with the blood, now they are undergoing contraction, and this contraction is starting from this place and it is going sideways. Yes or no? Starting at the apex and then it is going on the lateral sides. Please understand this one. This is very important when we study about the ECG. To understand NCRT sentences, you need to understand this. So in this way, wave of contraction is starting at the apex and then it is spreading like this. In this way, they are undergoing contraction. When they are undergoing contraction, what happens? Volume is keep on decreasing. Volume decreasing means pressure increasing. Now what happens? Here is the pulmonary artery. Now blood from this is going into the pulmonary artery, so that now it will be pumped to the lungs. And at the same time here the aorta is present. Now the blood from this left ventricle is going into the aorta, so that it is supplied to the body parts. And this is what happening during the ventricular systole. So during ventricular systole, what happens? Tri and bicuspid valves will be closed and these semilunar valves will be open. Yes or no? This is what happening. And after this, what happens? Ventricular diastole will occur. So that means they are undergoing the relaxation, muscular relaxation is occurring. So volume increases, pressure decreases. Now what happens? To prevent the backflow, semilunar valves will be closed, but here tri and bicuspid valves will be open, so that again the blood from the atria is coming into the ventricles. So in this way now again it is the joint diastole. Once again the same cycle will be repeated for several number of times. So in this way we are calculating this one. Clear? Now we will talk about the heartbeats. So please remember here one action potential from the SA node, one action potential from SA node, sinoatricular node or sinoatrial node. Okay. So from the SA node, one action potential is passing means it will result in one cardiac cycle. It will cause one cardiac cycle. Because of this one cardiac cycle, we are calling this one as one heartbeat. Please remember. So one heartbeat is nothing but one cardiac cycle. So one cardiac cycle is due to one action potential. So in this way, what is the average number of action potentials by SA node? 72 per minute. 72 per minute. That means in 1 minute how many cardiac cycles will occur? 72 cardiac cycles will occur. That means how many times heart will beat? It is beating for 72 times per minute. This is the average. So in this way, this is the relation. If this particular number is changed, obviously these numbers also will be changed. So in this way, generally we are calculating the number of beats per minute. We are calculating. So in this way, on an average, it is the 72 times per minute. So in this way, for 1 minute, 1 minute will have 60 seconds. Yes or no? 1 minute is having 60 seconds. You can write like this or simply just write smallest 60 seconds. And here in this 60 seconds, 72 beats. So 72 beats per minute. So in 60 seconds, 72 beats. 60 seconds, 72 beats. That means for one heartbeat, how much time it will take? Do the cross multiplication. So how you will do this one? 60 divided by 72 and you will get the answer approximately 0.8 seconds. 0.8 seconds. That is the reason why in one cardiac cycle, the duration for one cardiac cycle is 0.8 seconds. Please remember this one. This is why in the previous lecture we talked with respect to 0.8 seconds. This is what the overall calculation is. I hope now we understood this. Clear? So in this way, in that 0.1 second, with respect to atria, if you are talking 0.1 second atrial systole and 0.7 seconds atrial diastole. If you are talking for ventricles in the same duration, ventricular contraction is for 0.3 seconds and ventricular systole is 0.3, ventricular diastole is 0.5 seconds. But if you are talking about joint diastole, that means both atria and ventricles are in the diastole. What is the duration of this? It is 0.4 seconds. Many students are writing 0.5. That is wrong. It is 0.4 seconds only. Okay. Both of them should be in the diastole. That is the 0.4 seconds. This is what they are saying. Understood or not? So in this way, since for one beat it is 0.8 seconds average, so that means approximately half of the time, that means 0.4 seconds, both atria and ventricles are in the relaxed state, that means in the diastole condition. So in this way, we are studying about some information related to this cardiac cycle and then number of beats. And now we are talking about the two important words. One is called as stroke volume. One is stroke volume and the other one is cardiac output. First we will see the stroke volume. What is this stroke volume? The volume of blood pumped by each ventricle. This word is very, very important for examination. Each ventricle in one heartbeat. That means in one cardiac cycle. So this is what we are talking about, the stroke volume. So in one heartbeat, how much of blood is pumped here? By whom? By each ventricle. What is the meaning of this each ventricle? So will you add this or will you count only once? Now let us see. How much volume it is sending? Now please here, during the contraction, now this is the right ventricle, this is the left ventricle, right? Nice. So during this contraction, both the ventricles are contracting at the same time. And now this is sending 70 ml to lungs, whereas this one is sending 70 ml to body parts. to body parts. So during the ventricular contraction, right ventricle is sending blood to the lungs, right? How much? It is 70 ml. And left ventricle is sending blood to the body parts, right? How much? It is 70 ml. Approximately it is the 70 ml of the volume of blood that is pumped by the heart during each beat, each heartbeat. Clear? This is what the basic information. Now tell me, what is the stroke volume? What is the stroke volume? By each ventricle you are saying. So when you are calculating the stroke volume, what you will say? Will you say stroke volume as 70 ml or 140 ml? Now tell me. I gave the entire information. Now listen the question. So what is the stroke volume? So what you will consider here? Will you add 70 plus 70 or will you take only single 70? So this is the point you need to understand. Here they are talking about each ventricle. So you need to count only one ventricle. One ventricle. So how much this ventricle is sending? 70 ml. How much this is sending? 70. So what is the answer? 70 only you need to take. Some students, what they are doing is they are adding the 70 plus 70 and they are making 140. That is wrong. You need to take by one ventricle only. So for each ventricle, if you're talking, each ventricle, this is also 70, this is also 70. So take anyone. So anyone you just take. So what will be the answer? 70 ml. So what is the stroke volume here? It is the 70 ml. So in each heartbeat, how much of the blood that is pumped here? 70 ml is pumped. But please remember here, even though 70 ml is pumped, still some volume of blood is present inside this. Still some volume of blood is present inside the ventricles. Please remember, ventricles are not completely emptied. Still some volume of blood is present inside this. Okay. So generally each ventricle, now it is having approximately 120 ml of the blood. Out of this 70 ml it is sending. So these calculations and all the things under the extra information I will cover, because in NCERT they have not given these particular details. So those things I will discuss under the extra information lectures. Clear? This is what about the stroke volume. Nice. So please remember, in the stroke volume we are counting this particular volume in one beat. One beat you are counting. But there is another word that is called as cardiac output. Cardiac output. Cardiac output. How you are calculating cardiac output? From one ventricle only you need to calculate. From one ventricle only you need to calculate, but for 1 minute you need to calculate. So that's why how you will get this. So stroke volume multiplied with number of beats per minute. So this is what, how to calculate the cardiac output. Cardiac output is equal to stroke volume, whatever is the stroke volume, that one multiply with number of beats per minute. So in 1 minute how many beats? Average we have taken 72 beats. So that's why cardiac output is equal to, what is the stroke volume? 70 ml into number of beats per minute is 72 per minute. 72 per minute. So in this way multiply this one. So when you are multiplying this one, what happens here? So 0 you just take it here, 7 2s, 7 7 49 50. So this much you are getting here. Yes or no? This much you are getting. This is per minute. So in 1 minute, what is the volume of blood that is pumped by the heart? By the heart means what? Again, each ventricle. Technically, if you are talking, it is by each ventricle you are talking. So how much of the blood that is pumped here? It is approximately 5040 ml. When you are converting milliliter into liters, it will be 5.040 liters per minute. So anyhow, you can ignore this 040. So you can say that it is 5 liters per minute. So approximately 5 liters of blood is pumped through the entire heart, through the heart in 1 minute. And not only this, what is the general volume of the blood that we are having? The volume of blood that we are having in our body is also approximately 5 liters. The total volume of blood we are having is 5 liters, and heart is able to send 5 liters of blood in 1 minute. So technically, if you are observing, so whatever the blood that we are having in our body, that entire blood will be circulated through our body in 1 minute. Like this also they can give this interpretation. So please understand this particular calculation. So once again I am telling you, stroke volume calculation we are doing for one heartbeat, and that too for one ventricle. So that's why it is 70 ml. But cardiac output we are calculating in 1 minute. So here we are taking stroke volume and then number multiply with number of beats per minute. So we are getting this particular value. So approximately 5 liters of blood will be pumped by the heart. By the heart means, once again I am telling you, by each ventricle. So please remember this, and that is called as cardiac output. That's it. This is what about the stroke volume and cardiac output. Next we are talking about the heart sounds. Heart sounds. This is also another important one, but you can easily understand this. So what are these heart sounds? Please remember there are so many sounds are there, but at the level of class 11th we are talking only 2 sounds. Okay, so what is the first heart sound? First heart sound. First heart sound is called as lub, and sometimes they are writing this one as lup. Both of them are same, so don't worry. Next one, second heart sound. Second heart sound. If you are listening this particular one with the help of the stethoscope, you can easily understand these things. So you can observe this as dub, or sometimes they are giving this as dup, or sometimes they are giving double P also, D-U-P-P also they are giving. All these are same only, dub or dup, whatever it is, all these are same. In the NCERT they have given these particular spelling, so please follow this. So what are these heart sounds, and when you are listening these sounds, now who will make these sounds? Please observe carefully. We here, please remember once again I am telling you, here we are talking only about the sounds, first and second sounds, and these are caused by the valves. And what are the valves that are causing this? And when they will cause this particular sound, observe carefully once again. Once again we are starting with the joint diastole. Once again let us come to the joint diastole. During the joint diastole, what we are saying? During the joint diastole, tri and bicuspid valves are open, and then the semilunar valves are closed. Semilunar valves are closed. Yes or no? During the joint diastole, tri and bicuspid valves are open and semilunar valves are closed. For these only we are talking. So now what we are saying, after this atrial systole will occur. During atrial systole, condition is exactly same. These two are open and these two are closed. So condition remains same. But during ventricular systole, what happens? Volume of the ventricles are decreasing, so pressure is increasing. So there is a chance that the blood in the ventricle may go back to atria. So to prevent this backflow or reverse flow, now what happens? Tri and bicuspid valves will close. When they will close? During ventricular systole. You need to understand these relations. During ventricular systole, tri and bicuspid valves, bi and tricuspid valves close. They are closing. So when they are getting closed, so during that closure, they are making a sound. That sound is the lub. And this is the first heart sound. Please understand this very carefully. When we are observing this first heart sound, during the ventricular systole, during the ventricular contraction, at that time, bi and tricuspid valves will close and they are making the sound, and that sound is called as first heart sound. The sound appears as lub or lup. Understood or not? This is what they are saying. Next one, when we will see the second heart sound. Okay, ventricular contraction is happening. Nice. So that blood is going into pulmonary artery and aorta. Nice. And then again, after this, ventricular diastole will occur. Ventricular diastole. So what happens during the ventricular diastole? During the ventricular diastole, now the volume is increasing, so pressure is decreasing. Now again, these tri and bicuspid valves will open. Nice. But what about the semilunar valves? To prevent the backflow of blood from pulmonary artery and aorta, semilunar valves will be closed. When these semilunar valves are getting closed, at that time they are creating a sound, that is the second heart sound, that is called as the dub. So in this we have two prominent major sounds that we are observing. But anyhow, you will study about some other sounds also in the higher classes, but at this level these two sounds are enough. So first heart sound we are observing during ventricular systole, and it is due to closure of bicuspid, also called mitral valve, and also tricuspid valve closure. So since these cuspid valves are closing here, so there we are observing this first heart sound, that is the lub. During the ventricular diastole, now these semilunar valves of pulmonary artery and aorta are getting closed and they are making the sound, and that sound is appearing as dub, and this is called as second heart sound. This is the basic information regarding the heart sounds. I hope now you understood this. So all these things are interlinked with each other. When you are studying the cardiac cycle, we need to study all these things. General procedure we need to study, and the stroke volumes also, cardiac output also, and then this heart sounds also we need to study. So with this, the entire cardiac cycle will be completed. So with this, cardiac cycle information is completed, and now let us quickly go through NCERT content. After that, we can go with the ECG information. Okay, now let us quickly go through this. Stroke volume, volume of the blood that is pumped by each ventricle in one heartbeat is called as stroke volume, and cardiac output is the volume of blood pumped by each ventricle of heart in 1 minute. So how to calculate this? Stroke volume into number of beats per minute. That's how we are calculating that. Next one is regarding the heart sounds. Lub, this is the first heart sound that is observed during ventricular systole, and it is due to closure of tri and bicuspid valves. Dub or dub, this is the second heart sound. This is observed during ventricular diastole, and it is resulted due to closure of semilunar valves. This is what the information is. Now let us quickly go through NCERT content. This sequential event in the heart, which is means regarding the cardiac cycle they are talking. So already in the regarding the cardiac cycle in the previous lecture, basic information we studied. So that events cardiac cycle is sequentially happening for several times. So this sequential event in the heart, which is cyclically repeated, is called as cardiac cycle. The same process is repeated for several times, and each time since it is repeated, that is called as one cycle. In this way, whatever is the number of cycles, that will be equal to the number of heartbeats. That's what they are saying. And it consists of what are present in the cardiac cycle? Systole and diastole. Means systole is the contraction, diastole is the relaxation of atria and ventricles. So in this cycle, atria are also undergoing systole and diastole, ventricles are also undergoing systole and diastole. All the things are present here. As mentioned earlier, the heart beats 72 times per minute. So why it is 72 times per minute? Because SA node is generating 72 average, on an average 72 action potentials in 1 minute. That's why 72 times it is beating. That is that many. That many means what? 72 cardiac cycles. That means 72 heartbeats means 72 cardiac cycles are performed in 1 minute. So one action potential is equal to one cardiac cycle, that is equal to one heartbeat. This is the relation. So please understand this. Next one. From this, it could be deduced that the duration of cardiac cycle is 0.8 seconds. 1 minute is having total 60 seconds. In 60 seconds, 72 times heart is beating. That means for one heartbeat, what is the average time it is taking? 0.8 seconds. Simply, it is the division. Next one. During cardiac cycle, each ventricle pumps out approximately, each ventricle, underline the word each. Okay, each ventricle pumps out approximately 70 ml of the blood, and this is called as stroke volume. So with respect to each ventricle you are calculating. So for one ventricle it is 70 ml, that is called as stroke volume. The stroke volume multiplied by heart rate. Heart rate means what? Number of beats per minute. If you are multiplying like this, this gives the cardiac output. So in this way we are getting the cardiac output value. Therefore, the cardiac output can be defined as volume of blood pumped by each ventricle per minute. In 1 minute, each ventricle how much of blood it is sending. So this calculation is averaging up to 5000 milliliters or 5 liters in a healthy individual. This is that for normal individual we are doing the calculation. The body has the ability to alter the stroke volume as well as the heart rate. That means, see, under the resting condition for the normal individual, this is the value. Suppose you are running, then heartbeat will be increased and the cardiac output also will be increased, because when we are running, what happens? Now our body, tissue, cells, they need more and more nutrients and oxygen. So they have to be supplied very quickly. So now more volume of blood will be pumped, and also more times, means heart rate also will increase. So in this way, according to the situations and conditions, these volumes may be changed, these values may be changed. That's what they are saying. So ability, so we have the ability to alter means change stroke volume as well as heart rate. So both of them we can change as per the requirement, thereby the cardiac output. That means in this way, if stroke volume and heart rate are changed, cardiac output also can be changed. For example, the cardiac output of an athlete will be much higher than that of an ordinary man. So if you are talking about some individuals, so some people they have the habit of doing some sports activities. So those who are actively involved in the sports activities, for them what happens is their heart will be adjusted in such a way that their cardiac output will be more, because generally they need more supply of the blood and all. Yes or no? That's why when compared with ordinary man who is having the normal activity. So when compared with them, the people who are involving in the sports and all, so generally they will have more cardiac output. This is what the reason is. So that's why generally the marathon runners, so generally they will have the more cardiac output. That's why they are able to manage, even though they are continuously running for approximately 42 kilometers. In the marathon running, generally they will run for 42 kilometers. How they are able to manage it? Because of their high cardiac output. Please remember. So in this way, okay. Next one. During each cardiac cycle, two prominent sounds are produced. Two important sounds we are observing, and which can be easily heard through a stethoscope. With the help of stethoscope, we can easily observe these sounds. The first heart sound is called as a lub. You can also write it as lub. Is associated with, and it is related with what? Closure of tricuspid and bicuspid valves, means during ventricular systole this is happening. Whereas the second heart sound, that is the dub or dub, is associated with closure of the semilunar valves. Closure of semilunar valves is linked with ventricular diastole. So please remember this. And these sounds are clinical diagnostic significance. So if there is a problem in those particular valves, and the sounding will be a little bit different. So based on this, we can understand, are there any issues with these valves or valve closures or something. Okay. So that's why they are having some important significance in the clinical identifications. Clear? With that, that particular cardiac cycle concept is completed. Now we are going into another concept that is called as ECG. ECG, the term ECG we are using for both the things. What is that? If you are talking with respect to the instrument that we are using for measurement of this, that instrument is called as electrocardiograph. Please remember, instrument is called as electrocardiograph. And once you are getting the report, generally they will give the report on a graph paper. It will be a graph paper. On this you will see like this for the healthy individual. Yes or no? That graph paper, that report that you are getting, that is called as electrocardiogram. Don't get confused. Some students, what they are thinking is the report you are getting is a graph paper. So that's why they are calling that one as electrocardiograph. That is wrong. Instrument is called as electrocardiograph, and the report that we are getting, that is called as electrocardiogram. Please remember these names. But whatever it is, in short, for both of them you can use this ECG. So that's why this ECG is the electrocardiograph. It is an instrument that is used to monitor or measure the electrical potentials of the heart. Why you are measuring the electrical potentials? Please remember here. So when we studied about the nodal tissue, there we studied about SA node, AV node, all these things, and they are generating some action potentials. What are these action potentials? Action potentials are actually some electrical charges or the differences that are generated across a cell. Suppose you are talking about a cell. Suppose this is a cell. Generally in a cell, what happens is, across the membrane, if you are calculating the charges, you just count total charge outside the membrane and total charge inside the cell. Outside the cell and inside the cell, you just count it. And if you are having, suppose 2 positives are there, suppose 5 negatives are there, suppose 2 positive, 5 negative, or some 100 neutral are there. 100 neutral means there is no charge contribution. If 2 positive, 5 negative are there, what is the net charge here? It will be 3 negative. Net charge will be what? 3 negative. So in this way, outside, inside, you just calculate. And then generally what we are observing, that inside it will be negative, outside it will be positive, and this inside negative, outside positive is also comparative. That means the charge when we are comparing inside the cell, outside it is more, outside more it is positive, inside less it is negative. In that sense, as a relative comparison, we are giving these particular things. So normally under the resting condition, we are generally observing this type of charge, outer positive, inner negative. This is what we are observing, and this is called polarized state. It is called as polarized state. Please remember, regarding this particular mechanism with respect to neuron, under the neural control chapter we will study. But here now, to understand the NCERT sentences, there they are using a word called depolarized, repolarized. So what is this polarized first? Then you will understand what is depolarized. Then you will understand what is repolarized. So for that purpose, I am giving just a rough idea. That's it. So in a normal cell, across the plasma membrane, if you are observing this electrical potential, now it is inside negative, outside positive. This is the normal resting condition. So this is the polarized. Some polarity is there. So one side one, other side other one is there. But what is that one? Outer positive, inner negative is generally present, and it is the polarized state. And when it will be depolarized, depolarized means across the membrane some mechanisms will occur. So that means something is coming inside, something is going outside. So that overall what happens? I will give you a conclusion. In the depolarized, D means what? Removal of polarity. Polarity is lost. Polarity is lost. First you need to know what is polarity. Outer positive, inner negative is the polarity. And that polarity is lost. That polarity is lost means what actually happens? Reverse. It will become outer negative, inner positive. Please understand, this is what happening in the depolarized state. Under normal polarized state, inside negative. But in the case of depolarized, inside it is becoming positive. That means original polarity is lost. Now it is not having original polarity. Now it is having something opposite. So this condition is called depolarized condition. Please remember, this condition will cause muscle contraction. Please remember, depolarized condition for the muscle cells. In the muscle cells, if depolarized occurs, it will cause muscle contraction. It will cause muscle contraction. Very, very important for examination. Please remember. And with respect to muscle contraction, once again we will study under the locomotion chapter. Here we don't need to study this thing. Simply to make you aware of these words and their meanings, I am telling you this. So in this way, once polarity is reversed, it is called a depolarized condition, and it is causing the muscle contraction. Once muscle contracted, again it should relax. When it will relax, once again it will become normal. Once again normal means what? Outer positive, inner negative. Once again it is becoming again polarized. This is the normal polarized, right? So now it is again. So initially it is polarized. During this contraction it is depolarized, and after that again it is undergoing repolarized. Re means what? Again polarized, repolarized. So what actually this repolarized indicates? This is the muscle relaxation. Muscle relaxation. Please understand this. So in this way, in the NCRT, they are talking about the two names. What are these two names? In the NCRT, they are using the two names. One is called as depolarized condition. So what is this depolarized condition related to? Now let us see these words one after the other. We are using the word called depolarized. If you understand these words, ECG you can easily understand. Depolarized. What actually happening in depolarized? Depolarized is related to muscle contraction. Depolarized is related to muscle contraction. Now we are talking about another one that is called as repolarized. Repolarized is about muscle relaxation. Next one is repolarized. Repolarized is about muscle relaxation. This is the general information. Now this general information we will link up with heart. In the case of heart, now atria are present, ventricles are present, whatever it is. Muscle contraction. If atria are undergoing contraction, it is called as atrial systole. If ventricles are undergoing contraction, it is called ventricle systole. So whatever it is the systole. Understood or not? If atria are undergoing depolarization, atrial systole will occur. And if ventricles are undergoing depolarization, ventricular systole will occur. This is what the meaning is. So these are the related words. If you understand this relation, then only you will understand the concept. Now repolarized is the muscle relaxation. So what is this relaxation is called? Diastole. This is called as diastole. If atria are undergoing repolarized, atrial repolarization means atrial relaxation, and ventricular repolarization means ventricular diastole, ventricular relaxation. These are the words. So now in this ECG we will use the words, but since in the ECG, see, now you need to understand two things. Two things are there. One is ECG where we are measuring electrical potentials. Measuring in the ECG, what we are doing? Measuring electrical potential. And this electrical potential we are measuring in the ECG. And the other one is actual heartbeat in heart. Actual heartbeat that is happening inside the heart. So please understand this. Here one thing is, first electrical potential is generated. Because of this electrical potential, please remember, first electrical potential has to come. After the production of this electrical potential only, now this heart will respond accordingly. Yes or no? So two things are there. One is measurement of electrical potential. After this electrical potential, now heart will undergo contractions. So these are the things that were happening. So two things are there. And what actually this ECG report is showing, that electrocardiogram, what it is showing, and this is showing electrical activity during the heart contraction. Understood or not? Only the electrical activity. So which one is undergoing depolarization, repolarization, those things only it is showing. But please observe carefully, when actually you are observing about the nodal tissue, when actually you are talking about the nodal tissue here. Now let us see this. Now here I will draw the ECG. Here I will draw the ECG, and here I will talk about the nodal tissue. Nodal tissue I will talk here, and then I will talk about the cardiac cycle. Cardiac cycle. These are the things, three things we need to combine with each other. Three things that we need to combine with each other. Then only you will understand the concept. So I will go a little bit slow. So please try to understand the information. One by one I will write it. So accordingly, please try to observe this. In the nodal tissue, there is SA node, and here AV node is present. Yes or no? Now initially what happens? From the SA node, the information is passing on to both the atria and also going to the AV node. This is the first thing that is happening. What is that information? That information is nothing but action potential. And this, what is the result of this action potential? Here first, please remember, first action potential will be generated. This is indicated with P. There is an action potential that is generated here. And this action potential is indicated by is measured by the instrument. And you can see this as a small wave on the paper. And what this wave is indicated as? P wave. Nice. So please remember, first instrument is measuring this particular wave. And once you are getting this wave, so that means first information is going. After going information only, original contraction will occur. Atria will undergo contraction. Because of atrial contraction, what happens? Blood from the atria will go into corresponding ventricles. So technically, if you are observing, first P wave will come. First P wave will be measured. After that, originally inside our body, atrial contraction will occur. So if you are talking about this potential and this original contractions, first potential will be generated. So first you will see this particular peak. After that, originally it will undergo contraction. This point is very important to understand NCERT line. So please observe carefully. This is what happening. Nice. So in this way, so atrial contraction. What is this atrial contraction? It is the depolarization. Yes or no? So it is the depolarization that you are measuring. So P wave actually represents what? Atrial depolarization. P is actually what? Atrial depolarization. Please remember, when we are talking about P, it is with respect to the electrical potential. So what you need to say? It is atrial depolarization. Atrial depolarization means what will occur? What will occur originally here? Atrial systole will occur. Atrial contraction will occur. So in this way, P wave is actually related to what? Atrial depolarization. So it is causing atrial systole. This is the relation. So in this way, indirectly, if you see, atrial systole is related to P wave. This is what the information they are saying. Clear? Next one. Next one is from this AV node, now this potential has to be, first it is going through this AV bundle, also called as a bundle of His, and now from here onwards it is divided as right and left bundles, and also it is having some Purkinje fibers also. In this way it is distributed, yes or no? Now this particular one, now atrial contraction completed. So please remember, as far as this depolarization is there, until then only you will get the contraction. Once the depolarization is lost, now again it will undergo repolarization. For the repolarization, another information is not required. Once depolarization is going forward, Once that particular one is completed, automatically it will come to the relaxed state. So P wave. P wave is corresponding to atrial systole. So after this, what happens? By default, it will be undergoing the atrial diastole, atrial relaxation. But please remember, in the ECG, you will represent atrial systole, ventricular systole, ventricular diastole. But we are never representing, or you cannot see atrial relaxation, atrial diastole you cannot see. Why you cannot see this? Because when atria are undergoing relaxation, at the same time ventricular systole is also taking place and ventricular diastole is also taking place. So since these two are overlapped with atrial diastole, we cannot represent this atrial diastole in the ECG. So that's why in the ECG we cannot see the atrial diastole, but this will undergoing the diastole. So now once this contraction is completed, atria will undergo relaxation, diastole they are undergoing, that is the atrial diastole. But please remember that repolarization for atria we are not representing, because at the same time now what happens, now here it is happening, and then what happens is, and then now it is the QRS complex that is coming here. It is the Q, it is the R, and it is the S, that is the QRS complex. So this is the QRS complex that we are studying here. So observe this one carefully. So P it is, and then QRS complex is present. So what actually this QRS complex is? This QRS complex is related to QRS complex. What actually this QRS complex indicates? This is the ventricular contraction. So it is the ventricular depolarization. Ventricular depolarization. Ventricular depolarization. So what is the ventricular depolarization? Now ventricular contraction will occur. So ventricular systole will occur. Ventricular systole is occurring. Ventricular systole is occurring. But please remember, in the previous lecture we studied about cardiac cycle. There, what is the duration we studied for the ventricular systole? Ventricular systole, originally this entire ventricle contraction is taking total of 0.3 seconds. But please remember, you need to understand this logical point, because many teachers are not saying this. That's why some students are not able to understand the NCERT line. Please remember, when actually we are measuring this QRS, this is at this particular apex. Please remember, the contraction we are measuring at the apex of the ventricles, apex of the heart. Please observe carefully. We are not measuring for entire 0.3 seconds. Not for entire 0.3 seconds. We are measuring only at the apex. So that is the reason why, anyhow, not given in NCERT, for your understanding I am saying, what is the duration of this particular one? It is approximately 0.1 second. Please remember here, in the ECG, I am giving the average value. So please remember, it is having some plus or minus values are there. Let us, for your understanding, I am giving the one fixed value. So it is approximately 0.1 seconds. But originally ventricular systole is occurring for 0.3 seconds. But here it is, QRS complex is mentioning only for 0.1 second. And that's why after this again you will make it as a straight line. Yes or no? So this QRS complex actually is corresponding to this apex part of the ventricles. At this particular part you are measuring this. So that is the reason why the duration is a little bit lesser. But please remember, from this again the contraction is slowly going like this. That's why contraction is first starting at the apex, and slowly it is spreading to the other sides. Understood or not? So this is how the ventricular contraction is occurring. It is starting at this location, and then at that it is going towards the base side. So in this way the means ventricular contraction is occurring. So please observe this one. So in this way, QRS complex that we are measuring in the ECG is actually related to ventricular depolarization. That means ventricular systole. This is what. And the last one, after this, now there is a small peak. This is about the T. That is the T. Observe carefully. And what actually this T represents? T represents ventricular repolarization. Already depolarization is alright. It is the repolarization. Ventricular repolarization. Ventricular repolarization means what? Again it is diastole. So it is the ventricular diastole. Ventricular diastole. Now again after this what happens? Now again once again P will come, that is the next cycle. So in this way, in one cycle, if you are observing for one cycle, what we are observing? P we are observing, QRS we are observing, and then T we are observing. So that's why in NCERT they gave that. So these peaks are given with some letters like P to T. This is what they are saying. So this is the normal ECG for the normal individual. So if there are any issues with the heart functioning, now these will be variable accordingly. So doctors can predict. So what might be the problem there? And accordingly they will suggest for some other tests also. So based on that they can go for the further confirmation. So in this way, please remember the deviations in the ECG will represent there are some issues with the heart functioning. So in this way, this ECG is very, very important to know the normal functioning of heart. Understood or not? This is what the information they are saying. So in this, overall we are observing the P. P is related to atrial depolarization. It is corresponding to atrial systole. QRS is actually related to ventricular depolarization. So it will result in ventricular systole. And T is related to ventricular repolarization. So that is related to ventricular diastole. And once again I am telling you, before giving the NCERT sentence, the major conclusion is electrical potential will come first, then original mechanism will occur in the heart. That means ventricular depolarization occurs first, so that atrial systole will occur in the heart later. Next one, ventricular depolarization occurs first, after this ventricular systole will occur. And ventricular depolarization occurs first, after this ventricular diastole will occur. So this electrical potentials you can observe first, later on you can observe the original process in the heart. This is what the basic information you need to understand. This is what we are saying here. And now you just see it. What is the sentence they gave? The end of the T wave. End of T wave. End of T wave represents what? If you are technically speaking, what actually the end of T wave will represent? T wave is related to ventricular diastole. So what actually you are expecting? End of T wave. Generally what we are expecting, end of T wave represents end of ventricular diastole you are expecting. But in NCERT they gave, please observe this one. The end of T wave represents end of systole, they said. In NCERT they gave end of systole, they said. That's it simply. But which systole it is? It is ventricular systole. It is ventricular systole. And why they are saying ventricular systole? As per this particular information, we are expecting ventricular diastole. But why they are giving ventricular systole? Now this is a logical point. Observe very carefully. Just now I said no. Electrical potential will come first. After this, original process is happening. Now observe carefully here. So first, here this is for the atrial contraction. First P wave is coming. After that, originally atrial contraction is occurring. Nice. And then this QRS, now it is coming and distributed to the ventricle. But please remember that QRS you are measuring at the apex. At the apex we are measuring. And when it is at the apex and slowly it is distributed, so in this way slowly the information is passing on. So once this QRS is coming, after the QRS, then ventricular systole will be beginning from the apex on this both the sides. In this way it is starting. So then what happens? Again T wave. Please remember the meaning here. T wave also you are measuring at the apex. At the apex you are measuring the T wave. So this relaxation also should come from this to this one only. When contraction is starting here and going like this, relaxation also should happen in the same way. So now what is the meaning here? T wave is coming here at this apex. After the T wave, ventricular diastole should occur. So please remember, ventricular diastole is starting at this location. Ventricular diastole is starting at this location. But in NCERT what they are saying? End of the T wave is end of ventricular systole. They said systole, but it is ventricular systole. Why they are saying? T wave is completed here. T wave completed here, and before to this systole is happening, right? Because of this, that systole is ending here. Please understand the relation here. T wave is completed here. Before T wave, what was there? QRS complex was there. Because of the QRS complex, the ventricles are undergoing contraction. The ventricle contraction is starting here, going like this. And then relaxation is also starting from this. When relaxation is starting here, at that time, previous ventricular contraction is completed. So that's why T wave is completed here. At that time, ventricular systole is completed at this point. So that's why in this way they have given the relation. So end of the T wave here represents end of the ventricular systole here. But they have not given that much clearly. So simply they said that end of the T wave represents end of ventricular systole. In this way they have given electrical potential with original process. Since there is a time delay in between this, there is a small delay. So using that particular logic, they have given this particular sentence. In this way, simply they have analyzed this particular information, and for the normal ECG, this information is enough. Some extra information, some points that I will cover separately under the extra information lectures. So please go through them if you want some extra information. Clear? Now let us see. So here, how exactly we are measuring this particular thing. Now we understood this particular one. And for this one, so this electrical measurement should be taken. So generally what they will do is for both the wrists, they will attach these leads, yes or no, and then to the left ankle, So in this way, if you are observing in the T shape, suppose this is the human. So in this T shape, now they are attaching these three leads. Three leads will be taken. One is to this left arm wrist, and one is to the right arm wrist, and other one is to the left arm wrist, and other one to the left ankle. In this way they are attaching. Not only this, for additional extra, for proper data, means this electrical excitability, for the electrical excitability or the excitation or the electrical potential or the action potential measurement, they will attach some extra knobs also here. They will also helping in getting some information. So in this way, information from all these will be collected, and finally you will get this particular graph. Yes or no? P is related to atrial systole, atrial depolarization. QRS complex is related to ventricular depolarization, so ventricular systole. T is related to ventricular repolarization, so ventricular diastole. It is completed. Now once again it is the P of another cycle. This is from P to T, it is one cycle. Again next another P to T, another cycle. So in this way, how many cycles are coming in 1 minute? So based on that also you can know the heartbeat. This is what the information that they have given. Okay, this is the normal heartbeat. So in the unit time, if in that 1 minute, if more number of this QRS complex, simply you can say that one QRS complex is one heartbeat. So if many QRS complex are present, that means heart is beating fast. If less number of QRS complex are there, heart is beating slowly. Like this you can understand it. If there is some irregularity is there, so you can understand that there is some issue with the heart functioning. So in this way we are observing this. So this is with respect to the P wave, and this is with respect to the Q wave, and this is for contraction, this is for relaxation. That's it. Okay. Now let us go through NCERT content. You are probably familiar with this scene from a typical hospital. So generally in the hospital, so in the movies generally they are showing, no? So if this graph is keep on running, means the individual is still surviving. Whether heart is beating slowly fast, that is a different case, but at least you are observing, that means so still individual is working, means still individual is surviving, heart is working. So if heart beats are stopped, now what you will see? Now you will not see the graph. It will be like a straight line that is coming, and here it will say that pip 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 p, like this it is giving the sound, right? So when it is giving this p sound, means what? Done. Now heart is not functioning. Now generally then you may see that, so they are using some electrical fibrillator, and then they are keeping on the heart, so that now they are trying to give some electrical charge externally, so that sometimes cells may be activated again, so individual may survive in that case. So in this way they are getting ready for that particular emergency conditions. But here we are talking about normal condition. Let us see here. So generally in the hospital television, in that screen we are observing that a patient is hooked to a monitor machine. So in the generally in that TV shows or in the movies, generally they are showing this particular condition. Patient is connected with this electrical leads, and that shows voltage traces on the screen. On the screen you are observing this voltage potential that it is measuring, and it is displaying in the form of a graph, and it makes the sound pip 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 p, like this, as the patient goes into cardiac arrest. Heart functioning is stopped. Once heart function stops, now what happens? You will not see this particular one. So that's why the machine is giving that sound. That's what they are saying. And this type of machine is called as electrocardiograph, and the report you are calling it as electrocardiogram. Don't make any mistake. Machine is called electrocardiograph, that is used to obtain electrocardiogram. Report is the electrocardiogram. Please understand this. That is the ECG. And ECG is a graphical representation. Generally, it is there. They will give the uniform. It is on the graph paper. If you have seen that one, you will understand this. It will be like a graph paper. On the graph paper, you are observing all this. So what is the duration of each and everything? Everything you can clearly understand. But at this level, we are not worried. So leave it. So ECG is a graphical representation of the electrical activity of the heart during the cardiac cycle. During cardiac cycle, what is the electrical activity, whether it is depolarized, repolarized, where it is undergoing depolarization, repolarization, all these things we are studying there. To obtain a standard ECG that was shown here, this is the standard ECG. So to obtain this standard ECG, a patient is connected to the machine with electrical leads. Where we are connecting these electrical leads? One to each wrist, one to this right side, one to the left side we are connecting, and one to the left ankle, another one to the left ankle we are connecting. In this way, 3 leads we are connecting that continuously monitor the heart activity. So they are actually monitoring the heart activity. Next one, for a detailed evaluation of the heart's function, multiple leads are attached to the chest region. So at the chest region also they will attach multiple leads. So in this way they are getting the information. And here we will talk only about a standard ECG. For the normal healthy individual, what is the ECG? The only that one we are talking here. You don't need to worry about the disease condition. Simply ignore that type of questions. In some MCQ books, unnecessarily they are asking that information, so simply ignore that. Next one. Each peak in the ECG is identified with a letter from P to T. P we are using, QRS we are using, and then T we are using. This is what we are studying. That corresponds to a specific electrical activity of the heart. So in this way, that is related to. So each one is related to one specific electrical activity happening in the heart. Next one. The P wave represents, what actually P represents? Electrical excitation. Excitation, it is the depolarization. Excitation is the depolarization of atria. It will result in what? Contraction of atria, and which will leads to contraction of both the atria. So in this way, excitation is the depolarization that will lead to contraction, is nothing but a systole. If it is for atria, it is for atria. That's it. Next one, the QRS complex represents depolarization or excitation of the ventricular muscular cells. Ventricles muscular cells. So that what you will see, and which will initiate ventricular contraction, ventricular systole will occur. This is what, and the contraction starts shortly after the Q and marks the beginning of the systole. Once Q is started, so contraction is keep on happening. So it is a little bit slow, but this QRS complex will be completed very early, but the contraction is slowly happening, and it is taking approximately 0.3 seconds in the original contraction. Next one, the T wave represents the return of ventricles from the excited to the normal. From that depolarized, again they are becoming normal, means a repolarized condition. They are coming back to normal condition. That's why it is called a repolarization. And this is what actually it should actually represent the ventricular diastole. But here two different things they have combined. No? The end of T wave, originally what we are expecting, end of T wave should be end of ventricular diastole, but here they gave the end of systole. Which systole? Ventricular systole. Why they are giving like this? I told you, no, at the apex you are measuring, yes or no? For the ventricular repolarization, we are measuring at the apex, that is the T wave, but you are talking about ending of systole for the QRS complex. Because of the QRS, ventricular systole is happening, that is ending at the broader area, yes or no? So this is ending at this particular one. Contraction starting here, ending here. So in this way, T wave you are talking here, but for the contraction of the ventricle we are talking here. Yes or no? So in this way they are connecting two different points, so observe very carefully. So the end of the T wave marks the end of ventricular systole. In this way, electrical activity and original cardiac activity, they have combined like this. Next one. Obviously, by counting the number of QRS complexes that occur in a given time period, one can determine the heart rate. So one QRS complex is one heartbeat. In this way, you can consider this particular heart rate per minute or for a particular time point for an individual. Next one. Since the ECGs obtained from different individuals have roughly the same same shape for a given lead configuration, any deviation in this shape indicates a possible abnormality or the disease. For different individuals, if they are healthy, we are observing the similar type of pattern. So that's why if there is any deviation in this particular original graph, so you can observe that there may be some abnormality or a disease condition. Hence, it is of great clinical significance. That's why it is having a very, very great significance. In this way, in our syllabus, we are having the information only for normal ECG. So you don't need to worry about the disease condition. So please remember this. So with this particular concept is completed. So in the next lecture, we will study about different other points. Okay, we will meet in the next lecture. Thank you.